Now that we've spent time discussing all the measures of central tendency, let's move on to looking at measures of variability. Finding measures of variability can go hand in hand with finding the center of the distribution through the calculation of measures of central tendency. So what are measures of variability? Measures of variability tell us the amount by which scores are dispersed or scattered in a distribution. In other words, measures of variability give us an idea of the spread of our data from the center of the distribution. There are several different measures of variability, but the four we'll be covering are the range, interquartile range, or IQR, the variance, and the standard deviation. Different measures of variability can tell us slightly different things and might be able to be used with different types of data. Before we jump into talking about each of the measures, let's first briefly discuss the concept of variability. Remember that variability refers to the dispersion of the data. If we were looking at a simple data set or list of numbers, we should be able to get a general idea of the variability, but it might be hard to define any concrete characteristics about a distribution's variability without calculating specific measures. Let's compare data from two samples measuring the number of doctor's office visits in the past year. Both samples have the same mean, but if you look at the list of numbers or at the graph distribution, you can see that each distribution has a different level of variability. The data from sample 1 on the left appears to have less variability, as we can see that the observations were more clustered around the center of the distribution. The data from sample 2 on the right appears to have more variability, as we can see that the observations are more spread out away from the center of the distribution. The first measure of variability that we're going to discuss is the range. The range is the difference between the largest and smallest observations. To calculate the range, we'll identify the observation with the lowest value and subtract it from the observation with the highest value. While the range is fairly easy to calculate, it does have a few limitations. Since it only depends on two observations, the highest and the lowest, it is thought of as particularly sensitive to extreme observations. If you have one observation that is dramatically different, either higher or lower than the rest, your range will be significantly impacted and might not do as effective of a job in representing the variability in your data. Let's take our previous examples using data from our two samples. To find the range of sample 1, we would identify the highest observation, in this case 3, and the lowest observation of 1, and subtract the two to find a range of 2. In our second sample, we would identify the highest observation of 5 and the lowest of 0, and subtract the two to find the range of sample 2. If we were to compare the variability of the two samples simply by looking at the range alone, we can say that sample 2 appears to have more variability based on this range. The range can be calculated with any type of quantitative data. Let's move on to our next measure of variability, the interquartile range, more commonly known as the IQR. The IQR represents the range of the middle 50% of observations and is found by calculating the difference between the 75th percentile, also known as the third quartile or Q3, and the 25th percentile, also known as the first quartile or Q1. One property of the IQR that can be extremely useful is the IQR is not sensitive to extreme observations or outliers. One major shortcoming of the range is that it can completely depend on extreme observations, so it might not give us that representative picture of the data that we hope for. Since the IQR only measures the range of the middle 50%, it can ignore the few outliers that are either much higher or much lower than the rest of the data, and give us a more effective measure of the variability in the distribution and how much spread we have in the middle 50% of the observations. There are a few different methods for calculating the IQR, but they each should lead to approximately the same answer. The first key step is to arrange the observations in order from least to greatest. Just like with the median, failure to arrange the observations in order will completely affect the accuracy of your calculations. Once you've arranged the observations, the next step is to find the median of the data using the same methods we discussed previously for finding the median. Separate the two lists of observations at the median, resulting in a higher set of observations and a lower set of observations. You will then find the median of the lower set to get Q1 and the median of the higher set to get Q3 using the typical method for finding the median. Once you find the third and first quartile, you will subtract the 2 to get the IQR. A slightly different method you can use that should get you the same result is detailed in the textbook. You take the number of total observations that you have, add 1, and divide that number by 4. If necessary, round that number to the nearest whole number. You will start at the beginning of the ordered set of observations, and the number that you calculated will be the position of the first quartile, or Q1, from the beginning of the set. The number you calculated will also be the position of the third quartile, starting from the largest observation of the data set and moving backwards. Let's go over an example. Let's say you were working with previous example data from sample 2. Since the observations are already in order from least to greatest, you would first find the median of the data or the place that splits the set of observations in half. In this case, our two middle numbers would be 2, and the median would fall right in between these values and also be 2, splitting the data set into a lower and an upper half. The median, or the middle number, of the lower set would be 0, which would be your Q1. The median or middle number of the upper set would be 4, which would be your Q3. You would then subtract your Q3, or 4, and your Q1, or 0, to find your IQR, in this case, of 4. Using the other method, if I were to add 1 to my total number of observations, or 10, I would get 11. Dividing 11 by 4 would get me 2.75, which, rounded to the nearest whole number, would get me 3. The third position for my lowest observation, or 1, 2, 3, would get me my Q1, and the third position starting with my highest observation, 1, 2, 3, would get me my Q3, exactly as before. You would then finish the calculation of the IQR by subtracting 4 and 0 to get 4. Either method works well, so you're welcome to use whichever method you prefer. If you have an odd number of observations to start with, for example, if I added 6 to my list of observations, giving me a total number of observations of 11, there are two methods you can use to split the dataset into two halves. Either you can find the median or middle number on your list and ignore it, taking the numbers below for your lower set and taking the numbers above for your upper set, or you can include the median in both the lower and the upper set. Using either method, you would follow the steps we discussed after splitting the data set. I prefer the first method, but you are again welcome to choose either, as it just depends on the textbook you are using.